Okay, so we're just going to spend today kind of going over some vocabulary terms that students get confused a lot in the motion unit. And two of those terms that get confused a lot are speed and velocity. Um, and these terms are similar in that they both refer to how fast something is going. Uh, so the faster something goes, the more speed it has, the more velocity it has. Um, But speed and velocity are different because speed is a scalar and velocity is a vector. Scalars are just numbers, with units. But vectors are scalars, but they also include a direction. Um, and so I'll kind of give you some examples of the difference between vectors and scalars, and I think that might kind of highlight what I mean by vectors are scalars with direction. So, I'm going to give you some examples of speeds and velocities. So an example of a speed would be a car traveling at 25 meters per second. Pretty straightforward. A velocity, however, would be a car traveling forwards at 25 meters per second. Forwards being the direction, right? So in order to be a velocity, you have to include direction. A truck moving at 4 miles per hour, that would be a speed. A truck backing up at 4 miles per hour, that would be a velocity. Right? Backing up is the direction. An airplane flying at 800 kilometers per hour is a speed. An airplane flying north at 800 kilometers per hour is a velocity, right? North being the direction that the plane is going. A caterpillar crawls at 60 centimeters per minute. A caterpillar crawls down a tree at 60 centimeters per minute, right? Down would be the direction that would turn that speed into a velocity. Okay, so take some time, come up with some examples of your own of speeds and velocities, and write them out here. Um, that'll take some time, pause the video. I think that'll be really beneficial for you to sort of come up with some examples on your own of speeds and velocities. Okay, and so scientists would prefer to know the velocity of an object over the speed because it gives more information about the motion of the object, right? As a scientist, I can do a lot more if I know the direction that something's traveling along with how fast it's going, right, as opposed to just how fast it's going. Um, However, because we are studying objects that are moving in one dimension, we won't be listing the direction with the velocity of our objects for the most part in this unit. Instead, objects that are moving forward will have a positive velocity, and objects that are moving backwards will have a negative velocity. So for example, a toy car moving at 0.5 meters per second is moving forwards. A person moving at negative 1.5 meters per second is moving backwards. So hopefully that makes sense. Whoops. Okay, and so then another topic that often confuses students is the difference between distance and displacement. They are both measures of how far an object has traveled. Um, Distance is the total length of the path traveled by an object. Displacement is the length of the shortest path from the starting position to the ending position. So that might seem a little bit confusing. Let's just go through an example of that real quick. So here we've got an example of the difference between distance and displacement. So imagine like this is like, a person's at campsite A and they want to go to campsite B. So they, walk along this sort of winding trail from A to B. Now, if we took this trail and then we straightened it out and measured how far it is, or the length of that trail, that would be the distance. But the displacement is just the distance between campsite A and campsite B. Like if you were imagine like you were a bird and you could fly directly from point A to point B, that would be the displacement. And so the distance traveled by an object will never be less than the displacement between the starting and ending position. So basically, the distance and the displacement can be the same length if you're walking like in a straight line from one point to another. But in every other scenario, the distance will always be longer than the displacement. So unless you're walking directly from the point where you're starting to the point where you're ending, the displacement will always be shorter than the distance. So hopefully that gives you kind of some sense of the difference between these terms that sort of get thrown around in physics a lot. And then we're going to be doing a little bit with these in tomorrow's lesson. So let me know if you have any questions. But that will be all for today.